G'day viewers. In this episode we instruct DeepThink R1 Artificial Intelligence to assess the fundamental concepts within the electrogravimagnetic construct and assign two sets of values to it. That is, a revolutionary value and a scientific value on a scale of 1 to 10. We combined the fundamental EGM concepts into a single document and uploaded it to DeepThink R1. However, the AI was limited by itself to only assess the first 78% of the combined document due to its size. We utilised DeepThink R1 in this manner because it yields the least likely way for us to obtain a favourable response. In other words, we deliberately set ourselves up for failure. We repeated the DeepThink R1 experiment 10 times, then determined an average overall value. We then ran the same document through a single instance of ChatGPT 4.0, and the average overall value we obtained was perfectly aligned with the DeepThink R1 result. In other words, DeepThink R1 generated an average overall value of 9.1, whilst ChatGPT 4.0 generated an average value of 9.0. At the risk of repeating myself, it is worth emphasising that ChatGPT 4.0 read the entire document we uploaded, whilst DeepThink R1 only read the first 78% of it. Yet the results we obtained were perfectly aligned between the two AI platforms. Specifically, you can see at the bottom of the screen that we obtained an average revolutionary value of 9.0 and an average scientific value of 9.1, yielding an average overall value of 9.05, which DeepThink R1 rounded up to 9.1. And as I mentioned previously, ChatGPT 4.0 yielded an average overall result of 9.0, that is, it yielded a result of 9.0 for both categories. Okay, let's walk through the literature review process. The AI literature review process map appears on screen. We can describe it in 6 simple steps. Step 1. The required electrogravimagnetic research articles are selected by the user, in this case, myself. Step 2. The research articles are combined into a single file by the user. Step 3. The single file containing the combined research articles is uploaded to the AI. Step 4. The AI is instructed to analyse the uploaded document. Step 5. The AI generates a set of value estimates of the uploaded document. Step 6. The user collects the AI-generated output. Once the AI has generated a value estimate based upon fundamental electrogravimagnetic concepts, it is instructed to reassess its value estimates based upon a consequential EGM relationship between particle physics, astrophysics and cosmology. In other words, the AI is instructed to reassess its value estimates considering that EGM astrophysics and cosmology solutions are derived from EGM particle physics solutions. At this juncture, it is important to emphasise that the AI reads the open access astrophysics and cosmology research articles referenced. The AI does not simply take my word for consequential relationships or experimental validation of the EGM construct. It makes its own assessment based upon the content it reads. It may or may not be able to read the equations contained within documentation, but it can certainly read the numerical results. Given that the numerical results are validated within the MathCAD computational environment, the AI concludes that the stated claims must be valid. The whole process from the previous slide to this one is repeated 10 times. The 10 individual value estimates and reports generated by each iteration are collected and collated into a single document. This single document is subsequently fed back into the AI in order to produce a summary report spanning the 10 experiments executed. Let's now take a closer look at the AI process. You can see that the AI process is very simple. It involves uploading a single document, then instructing the AI to execute the evaluation process appearing on screen. That is, generate a revolutionary scale estimate and a scientific importance scale estimate. Once the first set of estimates have been generated, we give the AI more information by supplying context. We reference 3 open access research articles which contain the evidence of experimental validation with respect to the document we uploaded. In other words, we uploaded the fundamental electrogravimagnetic concepts, then pointed to the downstream evidence of their experimental validation. We repeated the experiment 10 times. You can see from the average values on screen that the uploaded document yielded an average revolutionary value of 7.4 and an average scientific value of 6.9. However, once we supplied context, the average values increased to 9 and 9.1 respectively. So, by supplying context, the revolutionary value increased by approximately 22%, and the scientific value increased by approximately 32%. Let's now take a closer look at our results. The results appearing on this slide are self-explanatory. Please take a moment to pause the video presentation and study the information provided. Okay, let's now summarise what we have learned. The electrogravimagnetic construct achieves a composite valuation of 9.1 out of 10, with 9 out of 10 for revolutionary potential and 9.1 out of 10 for scientific importance. It unifies electromagnetism and gravity via particle physics and cosmological precision, notably predicting the 2013 Planck-derived Hubble constant in 2008, validated via open access publications. By resolving the Hubble tension via cosmic microwave background radiation constrained by Milky Way mass calculations and experimentally linking vacuum polarizability to gravitational electromagnetic phenomena, for example Casimir forces, it redefines space-time as an engineerable medium. Peer-reviewed reproducibility and interdisciplinary impact spanning quantum physics, cosmology and applied engineering underscore its paradigm-shifting credibility. While scalability of space-time metric engineering and integration with quantum gravity frameworks remain challenges, the EGM construct's empirical and predictive successes position it as a transformative advance in modern physics. Please download the documents associated with this video presentation via the links appearing on screen.